The other element of basically an effective bilayer liftoff process is the liftoff itself. I mean, this is a major determinant in whether the masking structure is working, and it's essentially measured by how cleanly the sacrificial resist comes off, the uniformity of the deposit, the absence of defects like fencing or wings, which are related to the deposit material bridging or overspill into the undercut. We used basically a few approaches to assess that condition. One was basically a microscope and SEM visual inspection, as well as an EDS line scan analysis, looking for the presence of an oxide up onto the LOR sidewall. So that's the type of analysis that we're depicting over here with the images to the right. You can see one image essentially at the top is a picture of the lifted off area. You can see that the deposit edges are sharp, well defined. The resist has come off nice and complete and clean. And the EDS scan for that essentially shows good correlation, and no deposit of material up to the wall. So from assessing the structure stability geometry and the liftoff results, what's become apparent was this relationship between the top layer resist thickness and the deposit thickness. And that effectively helps to describe the cantilever condition from a stability standpoint. When you look at the ratio of the top layer resist to the deposit thickness, and you plotted that versus undercut, it revealed some very interesting correlations, largely a window of processing acceptability to get good liftoff and also essentially a stable structure.